As gamers, we're running machines with 4, 8, maybe 16 cores if we're lucky. So when AMD launched their first 96-core EPYC CPU, I figured, well, we're done here. That ought to be enough chip for even the most dedicated potato head.
But the Spudmasters at AMD said no, and last year launched a 128-core CPU. Surely, that must be enough, right?
No, it wasn't. And thanks to Supermicro, who sponsored this video, I have the brand new AMD EPYC 9965, a CPU with not 96, not 128, but 192 cores, making it, alongside its Turin family members, the fastest CPU on the planet by a wide margin.
We're talking 384 threads, terabytes of DDR5 ECC memory, 128 Gen 5 PCIe lanes, and a 500-watt TDP.
I can only think of one word.
What?
Holy sh**. I never thought I'd find myself saying, only 500 watts of power consumption on a CPU. But when you consider that AMD packed 192 cores into the same space they used for half as many just 2 years ago, you gotta agree, it's pretty impressive. I mean, sure, that's more than my entire first gaming PC, but compared to the King EPYC at that time, this new chip has double the core count and the same maximum boost clock for real-world performance that utterly obliterates it. So how did they do it? Well, for starters, just like AMD's latest Ryzen 9000 desktop processors, this monster is powered by Zen 5, which comes with a bunch of architectural improvements, like next-gen branch prediction, which allows these chips to predict their next move 2 steps in advance rather than 1, not to mention with greater accuracy and lower latency, all while increasing cache bandwidth, implementing a wider execution path, and adding a full 512-bit data path for AVX 512 workloads. If all that sounds like gobbledygook, that's fine. It boils down to a claimed 16% average IPC uplift from Zen 4 to Zen 5 in PC workloads, and potentially even more for high-performance compute and the enterprise workloads that typically run on servers. Let's get it installed.
But wait, while 500 watts seems downright reasonable for 192 cores, it does mean you can't just plop them into any old chassis and expect it to work. You need a compatible BIOS, sufficient cooling, and sufficient power. So keep that in mind. But it isn't going to be a problem for us today, since Supermicro can build practically anything, including this AS2126HSTN hyper server that they provided for this video. This magnificent machine can handle not one, but 2 of these monsters, which is 1,000 watts of just CPU. That's 384 cores, 768 threads. Oh. Now, typically, if you were to buy one from Supermicro, it's gonna come pre-assembled. But we went out of our way to take the CPU out so I can put it back in and show you how. These new chips use the same socket as last generation, so if you have one, you in theory could use it, but you are gonna want something that can handle more power. Not every motherboard is gonna be rated to handle a 500-watt CPU right out of the box. You should check your motherboard manual. This one, purpose built for this platform, so we should have no problems at all. PTM 7950, lttstore.com. It's a thermal pad and actually perfect for this application because it's super durable. These things can handle like hundreds or thousands of heat cycles while barely even losing any of their original performance, which is awesome. On a CPU this big, it's important to make sure everything is tightened down properly so that the CPU actually makes contact with all of those thousands of pins. Because unlike most desktop CPUs these days, the CPU is actually held in by the force of the cooler, not by like a little bracket on top. I mean, there is a bracket, but that mostly just kind of holds it in place while you're tightening everything down.
Order 1, 2, 3, 4, 5, 6, fully tightened, 1 at a time.
Yeah, not a little bit at a time.
Not a little bit at a time, which is the conventional wisdom, you know?
No, I tried to do that on one of the CPUs and it actually didn't post.
Look how scary that is. Gorgeous. Now, while we could have spec'd this machine with up to 9 terabytes of 6,000 megatransfer per second registered ECC memory across its 24 DIMM slots, that would have cost,
probably as much as my car, I think.
Yeah,
maybe
so.
More than both of my cars.
So I think the 1.5 terabytes that Supermicro sent over is gonna be plenty for us.
This is 6400. I heard that AMD is doing like special models with certain providers that support 6400.
That's incredible.
I guess this is one of them.
That's a big improvement.
Hold on. That means standard server memory is faster than standard desktop memory.
What hasn't changed from last gen is PCIe expansion. We still get 128 or 160 Gen 5 lanes in single and dual socket configs respectively, and this particular chassis can be spec'd for either 8 8-lane expansion slots or 4 16-lane expansion slots if we have dual width cards. They also crammed another 16 lanes into an OCP 3.0 mezzanine slot here, all of which, well, most of which we aren't using for now. But you definitely could. While our hyperserver is fairly well-rounded, a solid setup for virtualization, which we'll show you later, or cloud workloads where you need a lot of cores and not a ton else aside from memory, this chassis is also perfect for high-performance compute and even AI. I mean, you've already got the maximum amount of CPU, so with the rear slot stuffed with high-speed networking, GPUs, accelerator cards, maybe even all three at the same time, there's not a lot that a machine like this can't do. Don't wait! Today is the last day of our Black Friday and Cyber Monday deals at LTT Store. Grab some of the best deals of the year on screwdrivers, magnetic cable management, and more at lmg.gg/Black Friday. We're gonna have it linked down below. What we will be installing now is a few of these 15 terabyte Kioxia NVMe SSDs in the 8 slots that each support PCIe Gen 5x4. Funny thing about this chassis, by the way, if you're building out high performance storage for AI, or I don't know, something else that needs fast storage, maybe with software like Weka, it can be configured with up to 24 2.5-inch drive bays, thanks to the modular design of the front. So you could install an 8-drive backplane, like this one, in each section with a bunch of 30 terabyte CM7s, and you could have over 700 terabytes of Gen 5 storage in a single 2U machine. That's a theoretical read performance of 240 gigabytes per second across those drives in a single chassis, or more than 330 gigabytes per second if you went with 15s. You know, we get excited by fast SSDs in our gaming systems, but when you stack them up together in a stupid fast server like this, it's kind of mind-blowing. Speaking of blowing, if you're speccing 500-watt CPUs like we've got, or GPUs for AI or rendering, you might actually appreciate the modularity of this chassis and the fact that it doesn't necessarily have all those drive bays in there, because these are some flipping wild counter-rotating fans, but they're still gonna pull air better if they don't have a whole bunch of restriction in front of them. So the bottom line is, whatever your needs are, Supermicro's hyper systems and the entire rest of the lineup are designed with flexibility and modularity in mind. You ready to put the top on?
Did you look at the power supplies yet? 2,000 watts, 80 plus titanium. 2 of them.
Naturally.
What are the odds this boots first time?
With those giant sockets, even if you do it properly, like, I don't know, 85%, 90?
You did it properly.
Yeah. But I wasn't here when you put in the other one, so.
Whoa.
She's gonna go, she's gonna go.
These things take forever to post the first time.
That actually makes sense. Think how long your desktop Ryzen takes to do memory training the first time? Well, is it up?
On, yeah.
Oh, look. Oh, that's great.
And you doubted.
Well, I didn't doubt much. I said 85, 90%. All right, can I reboot it? Uh-oh. Oh boy.
I think it's set to max.
Yeah, I think so.
We should just leave it like that, right?
Yeah, maybe not.
Optimal speed, that sounds more manageable. Oh, thank God. Oh my God, that's, oh, that's downright pleasant.
Wow.
Now that we know it boots, we should probably put a GPU in there, right?
And what better GPU to go with the, top dog AMD EPYC Enterprise CPU than a top dog, not Enterprise, but still awesome, Radeon RX 7900 XTX. Now, despite this chassis being well equipped for GPUs, I mean, the power connectors are like right there, so they just plug right in. And they've got a 2600 watt power supply option that you can upgrade to. These slots are meant for full height, full length workstation and enterprise GPUs, not weird shaped gaming GPUs. So our plan is to put our GPU outside the server with a riser and a jumpered ATX power supply. Nice. Flawless.
Oh my God.
It scrolls! How much stuff can I do and still maintain 0% utilization? Could I launch a browser?
Oh, I'm sure you could play a YouTube video. It's only 1%. Oh, no, it's at 0 again. Once it settles in and it's doing its thing, it's nothing. It's gonna load 1 core?
It's 384 cores. It could load 2 cores and still be below 1%.
Duplicate this tab.
Well, hold on. First, I want to try different resolutions because we're not even at 1080p yet.
Remember, this is happening on the GPU.
CPU works a little harder. It works a little harder.
GPU's at 10%, so I think most of this is GPU.
Okay, 4K, here we go.
There's like some cores, there's 1 core I see at 9%. The rest of them are vibing. Thriving, one might even say. Okay, the GPU is at 77% according to Task Manager.
How is that even possible?
I think it's just because it's video decode.
Okay, let's disable hardware acceleration.
I think this is gonna hurt a little bit.
No.
2%.
Yeah, it's gonna hurt. It's gonna hurt so much. Our memory is 0% too.
It actually just says 0.0. But I guess to get to 0.1, we're talking
100 gigs. I need like a script to open these over and over again. I want to see how, maybe we should just revisit that video on this machine.
How many Chrome tabs?
We get some more RAM, we revisit how many Chrome tabs, but we like automate it this time. But let's move on. Let's move on for now. Cinebench, do you have R23 so we can see all the little things?
I do, but it wasn't launching.
Oh wow, it just does nothing.
No, I know.
It doesn't even try to...
I looked in Task Manager and you see it for a sec and then it goes away. I think it just doesn't know what to do with this many threads. And 2024 is going to be a supreme disappointment.
What?
It's thread limited to 256 for some reason. I don't actually know why. That's it? You didn't even say what the score is.
If that score was my child, I wouldn't even speak to it. Oh, what a flippin' disappointment. Get out of my sight.
You could try Blender.
Ready? CPU rendering, let's go. I feel like this is gonna take longer just to prepare the job than to actually render it.
It's a lot of blue. It's a blue screen of success. Damn, 12 seconds.
She doesn't get much clock speed though, does she?
Yeah, this is also running with SMT on. Like, we're kind of at the point where you have so many cores that I feel like a lot of applications are better off without multi-threading. Or some might be anyways.
These CPUs, between the two of them, have over twice as much cache as my first gaming PC had system memory. Like the first one I bought for myself.
Yeah, okay.
Cache!
Yeah, and these don't even have that much cache.
No. 7-zip can't perform that great. There's no way it'll go across this many threads.
CPU threads? Oh, what?
Limited again! Let's go compare this to Intel's new desktop chips real quick.
So 700 GIPS, which is 700,000 MIPS. So it's like 3.5 9950Xs. Oh, no. Wait, that's kilobytes per second.
Yeah.
Oh, I see.
Yeah, so we're double the performance, but like...
Okay, well now we should play a game on it, right?
Sure, I mean, we have to.
This is like the worst possible CPU to play video games.
Oh yeah. Okay.
We're at 4K, high settings.
Oh man, that was cheesy. Not gonna lie.
Okay, clearly this is not a gaming CPU.
I mean, it's working for me, what can I say? No!
You could probably run, if you had enough GPUs, like 60 instances of Counter-Strike at this point.
Dude, no though. Should we do it? It's been so long. How many years has it been since we've done many gamers, one CPU? This time, we could actually do one CPU with 192 cores? Dude, that would be crazy.
Yeah, we should do it.
I want to do it.
Here, did you know Alt F4 makes the game run faster?
Did you know that Alt F4 doesn't do jack in this particular game? No, I'm winning. I'm gonna win. I'm gonna win, Jake! Jake, I'm gonna win! Okay, what's next?
Doom Eternal's a good one, because Doom Eternal is actually like fairly multi-threaded, supposedly.
Here we go. Horde mode, 4K, everything ultra nightmare, motion blur off, ray tracing off.
Looks pretty good. It's 200 FPS.
Yeah.
Wow, it actually does use some cores, eh?
Yeah, but like...
I mean, relatively speaking, no, but...
That's crazy though.
It's actually using like 16 cores, I feel like.
But we're running at 200 FPS. That means we could run multiple instances of Doom Eternal on this thing.
Wasn't the CPU usage at like 1%?
Yeah. When I say multiple, I mean a big multiple.
All right.
This actually feels great.
let me
though.
click,
yeah,
click.
yeah. Click the things.
He's almost dead.
Glory
Just
kill him. Glory kill him.
use more fuel, buddy.
Oh my God, you're gonna die, Jake.
Oh no, oh no, oh no, leave me alone.
He called you an arrogant fool. Quick, glory kill.
I did it. Yeah.
Again.
Yeah.
Let's go.
Yeah, this is great. It's running lovely.
Okay, let's do something not stupid on it.
Passmark would be a good one because it'll show us like comparison to CPUs that are relevant. I bet you in a lot of cases, the numbers that we get running across both CPUs will be the same as running across one, or maybe even worse.
And that's just software limitations. But
Yeah.
you would never configure a system like this for a single workstation that's running one
A
task.
single workload.
Yeah.
Or at least if you threaded it across all of them, you would have them be well aware of the fact that there's two CPUs and the performance degradation you get when you try to cross them.
Yeah.
And we're literally off the chart
Yeah.
by like a lot. So nobody else has submitted this CPU yet. So let's run memory mark and then we can submit it
Sure.
and then we can see what it's like compared to other CPUs.
All right. One of the tests is just how much memory you have. I think we're gonna do okay on that one. Maybe okay. Oh.
63rd percentile.
Mid AF. The read and the write are gonna be strong because we just have 12 memory channels running at 6,400 megatransfers per second.
Click on memory threaded. Oh wait, what is that? So that's megabytes a second?
That's how far I have to zoom in to find the high end. Available RAM, let's go.
Yeah, we're definitely winning on
Let's
that one.
go.
I think maybe disk mark we have to do too. These Kioxia SSDs are nuts.
Could we be a little bit limited by our low thread speed though?
Oh, 100%.
Dude, do you remember how many drives we used to have to put together to see numbers like this?
Yeah. The crazy thing is like our storage server probably does 20 gigabytes a second
This is one drive.
with all those drives, but
This is one drive. Let's have a look at our compare here.
so this is last gen. This is the one we just tested.
That's a lot of generation over generation uplift.
Yeah, multi-threaded, basically 30% on the dot. From what I've read, like other applications can be 45% or more.
Well, that's what a huge increase in clock speed and core count is going to do for you. Zen 5 might have been a bit of a wet fart on the desktop, but on the enterprise side, it is anything but.
This is the result I did last night, which is finally posted.
Okay.
189,000.
And this is the master list of all dual CPU submissions.
Which, naturally, a lot of AMD in there.
Dude! We were so close to the top of the chart.
We're very close.
It's so close.
Kind of infuriating, actually.
Okay, what is this though?
That's the 64-core frequency optimized one.
That's only 64 cores per CPU.
Okay, but up to 5 gigahertz.
The first last gen EPYC setup is all the way down in 4th place, flipping 35,000 points behind us.
And those are the 3DV cache ones, which are very expensive. So that's our last gen competition.
Right.
So we're 60,000 points above that.
Absolutely huge generational uplift.
30%.
As cool as it is to see this many cores, to pack this many in, AMD had to design a smaller, denser version of their Zen 5 core called Zen 5C, presumably standing for compact because they actually squished the same functional units into a smaller space. So unlike efficiency cores you might see in other CPUs, they use the same architecture and actually a more advanced process node compared to the full-size cores, which pays off in a big way in power efficiency. But these compact cores do have drawbacks. AMD actually has a handy little visual to make this easier to understand. Smaller size, but the squishiness costs you in cache and it limits your maximum clock speed. So for our Many Gamers project, we're actually more interested in checking out the EPYC 9755. Sure, it's got 64 fewer cores, but they're the bigger, faster, cachier ones, which is pretty important when you're running that many instances of COD or whatever. Although, with that said, Jake, the 9575F, sure, only 64 cores, but if we had 2 of them running at that kind of frequency, maybe pretty interesting depending on how many GPUs we can get working. Anyway, all of this conversation leads us to a really important point. With the diverse use cases that you see in the data center space, there's no longer a one-size-fits-all chip or even core design that can be the master of every workload. Anyway, let's change gears and fire up some more appropriate workloads in Linux.
We're in Ubuntu, the latest one, 24.10, so very new kernel. This is one of those tests that I have a lot of context for. That's actually not that good of a score.
Dang it.
60 seconds. But here, watch this. Let's set it to only run on our first CPU. So we need to just copy. That's the cores. Those are the extra threads. Copy those. And Linux is so easy to do this. The only tricky thing is we have to tell YCruncher to be smart about it too. You can see it's only on NUMA node 0.
Yep.
Only using memory on NUMA node 0, which is important. And only using 384 threads, which is one CPU. 47 seconds, what were we at, 60 before?
Yeah.
So we picked up like 13 seconds.
By turning off one of our entire CPU sockets.
Even sillier, let's do just the cores, no threads.
Okay.
Damn! 42.3 seconds.
So what we're trying to say is more, not necessarily better.
Especially on an application like this, which is super memory bound. You do not want to be crossing CPUs unless you absolutely have to. Okay, this is last gen.
Yeah.
Bergamo. So we go from 60 seconds. Actually, see, they tried it with multi-threading and without. So we went from 60 seconds, which was our 2P time, down to 42.
Let's do something practical.
While it might not be practical, it is like a relevant use case. This is Proxmox, the hypervisor, and we're gonna make some virtual machines.
Well, that seems very practical.
Yeah, just not in the way that I'm gonna do it. We have all these cores, right? Well, I guess we're gonna need a few VMs. See what that's doing?
Oh, you're just copy pasting your VMs.
I'm a little worried it's gonna get upset that I'm doing
How many are you doing?
Like a few.
That's not actually that silly. I mean, massive parallelization of light compute workloads, that's actually right in this thing's wheelhouse.
Yeah, but it's like Windows 11 desktop. And,
Okay.
And I'm talking like 192.
Okay, yeah, no, normally it would be like AWS instances or something
Yeah,
like
like
that.
little Linux instances.
Yeah.
Yeah, I'm talking like
Running web services.
full desktop Windows.
Okay, that's really stupid.
But will it work? We have 384 cores. That gives us 2 cores of VM. That's not bad.
It's not great.
I put the one image on a RAID 0 of 2 of those Kioxia SSDs. And they're linked images, so if you look at the actual storage usage, it should be literally exactly the same as one.
That's pretty cool.
Usually when you bulk start VMs in Proxmox, it does them one at a time. But that takes too long. So I made a script to just do them all at once.
How's our CPU usage?
Oh yeah, it's
Good timing.
15%.
Yeah,
Look at the
okay.
RAM usage climb.
Oh my goodness.
I think I gave each of them 8 gigs or like 7.5 gigs.
Oh, you're running a YouTube video.
So we made a little script that when the Windows instance starts, it opens a random YouTube video on a list of like 250 that I plopped in there.
Can we run almost 200 instances of Windows and play back almost 200 videos with software decoding? That is flipping wild. Open up Task Manager on one of these. Let's see if it's actually struggling. Because it might very well not be. Sure, they're not clocked that high compared to some of the other chips, but they're Zen 5 for crying out loud. Like,
Once it's running, it's not doing that much. So I've only given it 2 real cores. I've only allowed them to use 2 real cores, and then it has 4 in here. So it's chilling out. Remember, it's still like booting up. It's like indexing Windows. It's probably checking for Windows updates. If these all start Windows updates, oh my God. Okay, so that's
not bad.
no way, dude.
I think it worked.
Are they all on? No way. This, because 192 instances of Linux, I don't know if it would be that impressive. I mean, this will be impressive.
Yeah.
But this is like Windows 11 Home Edition. It's not stripped down at all. I didn't disable anything. I literally installed Windows, booted it up, set the script to load. It's not optimized in any way, shape, or form.
How's our usage?
That's not bad, dude.
Half of our CPU.
Yeah, and of course the I/O delay, 0%. Shout out Kioxia. When you RAID 0 2 SSDs that can do 15 gigabytes a second each, pretty fast.
Bottom line then, it's pretty clear that this new lineup of EPYC chips is gonna pretty much dominate everything else on the market. Like, I've kind of lost track of the last time any of their competitors had a fighting chance in the data center, and I think AMD knows it. While core for core pricing hasn't changed much in the last couple of generations, let me say that another way. Core for core pricing hasn't changed much. So this 192 core chip will set you back nearly $15,000 at MSRP. That means that this one computer on its own has $30,000 worth of CPUs. For the right customer, where ongoing expenses like data center rack space, cooling, and power are the bigger concerns, this could be a very compelling value. So props to AMD, props to Supermicro who sponsored this video. You can check out their Hyper servers and the rest of their H14 EPYC 9005 server lineup by checking out the showcases that we did on the Supermicro channel, which we're gonna have linked in the video description. They have some wild stuff, like their new Flex Twins, which stuff 8 up to 192 core CPUs in a 2U. Like this size, guys. That's 1,532 cores. Or a casual 37-ish thousand in a 48U rack. Mind-blowing stuff. If you guys enjoyed this video, why not check out the one we made about our Supermicro Grand Twin and some sick AI video processing tech. That was super cool, and I'm kind of wondering, are we ever going to deploy that?
Yes.
Nice.